Welcome back to Advanced Skills Learning. Most RAG systems fail in a subtle way. Retrieval seems to work, chunks are returned, but the final answer still feels incomplete or slightly wrong. The issue is rarely the model or even the retriever. It is usually how your data is chunked. Chunking defines what the model can see, and if the right information is split incorrectly, the system cannot recover from that mistake. This is why many teams keep tuning models or retrievers, without realizing the real issue was introduced much earlier in the pipeline. Chunking is the process of breaking large documents into smaller pieces so they can be embedded and retrieved efficiently. These chunks become the building blocks of your RAG system, but here is the key insight. Chunking is not just about size. It defines the boundaries of meaning. If those boundaries are wrong, your system retrieves fragments instead of complete ideas, and the model is forced to guess what is missing. In other words, chunking is not just data preparation, it is actually shaping what the model is allowed to understand. Most systems use flat chunking by default. Documents are split into fixed-size pieces, like 300 or 500 tokens, without considering structure. This approach is simple and works well for basic retrieval. However, it assumes that meaning is evenly distributed across the document, which is almost never true. Important ideas often span multiple sections, and flat chunking breaks those connections. This simplicity makes it attractive, but it also hides deeper problems that only show up when the system scales. The biggest problem with flat chunking is that it breaks logical relationships. A single concept might be split across multiple chunks, and retrieval may return only part of it. This leads to incomplete answers because the model is missing key context. Even worse, the retrieved chunk may look relevant, but it does not contain the full explanation, forcing the model to hallucinate or fill in gaps. As a result, even high-quality retrieval scores can still produce low-quality answers because the context itself is incomplete. Consider a policy document where a rule is defined in one section and its conditions in another. If flat chunking splits these apart, retrieval might return only the rule without the condition. The model then generates an answer that looks correct but is actually wrong. This is one of the most common production failures in enterprise RAG systems, and it is very hard to detect without careful evaluation. And because the answer looks fluent and confident, these errors often go unnoticed until they cause real business impact. Hierarchical chunking takes a different approach. Instead of splitting blindly, it respects the structure of the document. Content is organized into levels, such as sections, subsections, and paragraphs. Each chunk is part of a larger parent, preserving context. This allows the system to retrieve not just a small fragment, but also the broader context when needed. This approach aligns much more closely with how humans structure and understand information in real-world documents. In hierarchical chunking, each small chunk is linked to its parent section. When a query retrieves a relevant chunk, the system can expand the context by including its parent or neighboring chunks. This creates a layered retrieval process where you get both precision and completeness. The model now sees the full picture instead of isolated fragments, leading to more accurate and grounded responses. This dynamic expansion step is what allows hierarchical systems to balance precision with completeness. Quick check. 2 seconds. Which statement is true? A. Smaller chunks always improve accuracy. B. Structure does not matter. C. Meaning can span multiple chunks. Keep your guess. The answer is C. Meaning often spans multiple chunks, and ignoring that is exactly what breaks most RAG systems. There is a clear trade-off between flat and hierarchical chunking. Flat chunking is fast and simple, making it easy to implement at scale. Hierarchical chunking is more complex and requires additional metadata and retrieval logic. However, it provides significantly better context quality. In production systems, this trade-off often determines whether your system feels reliable or frustrating. So the choice is not just about performance, but about how much correctness your use case actually demands. Flat chunking works well for simple use cases, such as FAQs or short documents where context is limited. Hierarchical chunking becomes essential for complex domains like policies, legal documents, or technical manuals. In many real-world systems, a hybrid approach works best, where flat chunking is used for speed and hierarchical expansion is applied selectively when deeper context is needed. The key is to match your chunking strategy to the complexity of the information you are trying to retrieve. Quick check. 2 seconds. What is the main benefit of hierarchical chunking? A. Flat chunking is always wrong. B. Hierarchical chunking adds context. C. Chunk size is the only factor. Keep your guess. The answer is B. Hierarchical chunking adds context. It adds context by preserving relationships, which is exactly what improves answer quality. Here are the key takeaways. Chunking is not just a preprocessing step. It defines how meaning is preserved in your system. Flat chunking often breaks context and leads to incomplete answers. Hierarchical chunking restores relationships and improves accuracy. If your RAG system feels unreliable, the problem is often not retrieval or the model. It is how your data is structured before retrieval even begins. Fixing chunking is often one of the highest impact improvements you can make without changing your model at all. Thanks for watching. If this video helped, like the video and subscribe to Advanced Skills Learning for more Gen AI explainers, practical architectures, and quick quizzes to test your understanding.